Right, so right now I'm doing solution stoichiometry worksheet 1, which is finding the molarity or the concentration. So this this worksheet, not just for double displacement, not just for neutralization. I'm just telling you acid and base is one kind of neutralization. And if acid and base react, water must be formed. Water is one of the liquid. So if the double displacement is not acid and base, is not neutralization, will be just regular double displacement reaction, how can you figure out the state of the product? Well, first of all, you know the two reactants must be aqueous, okay, because reaction take place, obviously, for the math. And then one of them is PPT, one of them will be aqueous. So the best thing to do, if it's a regular double displacement, how do you know which one's PPT, which one is aqueous product? Is using the solubility chart. Solubility chart will tell you which one's PPT, which one's aqueous. So in general, you first want to identify which one, the question, what you're looking for. Okay, I'm looking for the example here. I'm looking for molarity of nitric acid, and then the two reactant, one is nitric acid, one is potassium hydroxide. So we first want to write down their compound name. Okay, so I give you all kinds of acid and base name. So nitric acid is HNO3AQ. Potassium hydroxide is KOHAQ. This is the double displacement reaction. So do you remember you need to write out the charges for prince and princess, H plus, NO3 minus, K plus, and OH minus, and then we draw the rainbow, let them switch partner. And so the first rainbow, the blue one, it brings the K plus NO3 minus. So when they cross over back, I get KO3 minus, KaNO3. And then H plus, OH minus, the second rainbow, and they form water. Now if they form water, it's always water liquid. Then the other one must be aqueous, because based on double displacement, one of them must be water, one of them is AQ. Now again, if it is not a acid and base, okay, then it must be PPT and an AQ. How do you know which one is PPT and AQ? You do this all the time, is using the solubility chart to tell you. And then once you finish write out the state, your balance equation, next is we start to draw the question mark box. So the question mark box, like the box, okay, always have two information. Now, question mark box, what do we need to put on the top is, this is actually switch, okay, this is wrong. So the question mark must be on the top. So here, I'm looking for molarity of nitric acid, so I have to put the question mark molarity on the top. But the molarity, I need to change that to mole over L. And what's supposed to be go to the bottom of the question mark is whatever the honey, whatever left over. So nitric acid, I was given 10.0 ml. So I have to put 10.0 ml on the bottom of the question mark, but I can't put ml in the Superman. I have to change to liter. All right, that's just a question mark box. Now, what about the non-question mark box? The top must be something measurable. So I have KOH information. So 25 ml, 0.351 molar, 25 ml, 25 ml is the measurable. I have to put on the top, but I have to change to liter. And then number two is whatever left over, whatever the honey. So 0.351 molar must be on the bottom, and I change that to mole over L from the molar. So as soon as you write this down information, you can start to draw the arrow. You always start to draw the arrow from non-question mark box to question mark box, because this is exactly what you're trying to follow the direction of the Superman. And so you want to draw the arrow like this, and then the MR must be in the middle. So if you follow this, you can start with 0.025 L KOH, and then 0.351 mole over L. Well, how do I know L is on the bottom? Because I want to cancel the L. So 1 L KOH on the bottom, 0.351 mole KOH on the top, and then I follow the MR, which is the molar ratio, 1-to-1 ratio. And again, KOH must be on the bottom because I need to cancel. Now, if you follow this through here, you should have mole HNO3 left over. Now, I'm looking for molarity. molarity equals mole over L. So after the MR, I have to go to the volume. So volume liter must be on the bottom because molarity is mole over L. So if you set this up, you cancel all the necessary thing. Mole over liter, you cannot cancel. And here I would say HNO3, you don't need to cancel either because we will have that left over. So after you do your math, you will get 0.8775 mole over L and HNO3. But you have to round to 2 places and then change the mole over L back to molar. That's the original unit. So let's look up number 2 here. My number 2 is, again, what I'm looking for is molarity acetic acid. Acetic acid and sodium hydroxide are my 2 reactants. So we first write down the compound acetic acid I gave you, okay? And then sodium hydroxide, you know how to write this down. They are double displacement, so these 2 must be AQ. And then you form back the charges, the prince and princess charges, okay? And then you want to draw the rainbow, let them switch the partner. So the first rainbow is Na plus CH3CO minus. Again, the positive charge must be going first, negative charge must be next, and then the second rainbow. All right, and then you can cross over back to form the compound. Now, since this is water liquid, then this one must be AQ. All right, and then you balance the equation, so all 1, 1, 1, 1. After this, you want to start to write down the question mark box, okay? So I'm looking for molarity of acetic acid. So question mark box said that question mark must be on the top, and then whatever the honey, whatever left over must be on the bottom. So my question mark is molarity, so I have to put question mark molarity underneath acetic acid, but molar, I have to change to mole over L. And then the second of the question mark box is the honey. So whatever the information, 12.5 ml, I have to put on the bottom the question mark, 12.5 ml, but I have to change that to liter. And then for the non-question mark box, I was given 2 information. One is 0.504 molar, one is let's see, 20.65 ml. So which, based on the non-question mark box, which should be on the top must do one measurable. So the volume is measurable, so I have to put this on the top and then change to liter. And then the bottom, the second one of the non-question mark is whatever the honey. So the other information, 0.504 molar, we will change that to mole over L. So you have this 4 information, then you can start to draw the arrow. Again, the arrow always starts from non-question mark box. That means I should start from everything I have. I cannot start with question mark box because the question mark cannot be at the beginning of Superman. So I'm going to start to draw down the arrow going this direction, and middle must be MR. The direction, the arrow will tell you the order of the Superman. It's very helpful. Okay, so we start from the Superman is NaOH. We start with the liter. So 0.02065 L liter NaOH is number 1. And then we follow the arrow down is 0.504 mole over liter, also NaOH. So here I have to put the liter, 1 liter on the bottom because this actually has a definition of 0.504 mole over 1 liter. So 1 liter must be on the bottom because I need to cancel it out. NaOH cancel. 0.504 mole on the top. All right, so I cancel it out, cancel NaOH. I follow the arrow, I have to go to the MR. So MR is the molar ratio, 1 and 1. So 1 mole NaOH, and then on the bottom, and then 1 mole HCO3 COO on the top. Now we cancel the mole, cancel the NaOH. And then after the MR, we will jump to the liter, 0.0125 liter of the acetic acid. Now again, here I should not cancel anything because my mole over liter is molarity. So now the liter must be on the bottom. If you put the liter on the top, mole times L would not be molarity. Mole over L would be molarity. So here actually, if the period 2 or period 4 class, if I show you before, actually you don't need to cancel anything. You don't need to cancel any compound. You just keep it like this, okay? Mole over liter and the compound, just leave it, okay? And then if you do all your math together, you should get this number, mole over L acetic acid. Now you want to round it to two places. Mole over L, you want to change back to molar. Okay, mole over L, the actual unit is M, and then acetic acid. So this is number 2. And let me go to number 3 here. This number 3 is actually another kind of double displacement, but not like acid and base. It's just a regular double displacement. So we are actually having two reactants, aluminum chloride and silver acetate. And aluminum chloride molarity is what I'm looking for. So we first write down the aluminum chloride, AQ, right? It's a double displacement. Silver acetate, AgCH3COO, AQ. Now we draw the rainbow, right? We form back the charges Al3 plus, Cl minus, Ag plus, CH3COO minus. We draw the arrow for rainbow. So the first rainbow will be Ag plus, Cl minus, again positive first, negative next. And then Al3 plus, CH3CO minus will be the second rainbow on the cloud. So we cross over back, we will form AgCl and then Al parentheses CH3COO close 3. Now here it is not like a neutralization, so regular double displacement. How do you know that which one is PBT, which is AQ? In this case, we are not doing limiting reactant, we cannot tell. So the only way you can tell is look up the solubility chart. So solubility chart tell you that all the chloride are soluble except silver. So silver chloride is PBT, then this one must be AQ. And then after this, we balance the equation. Okay, I'm not going to repeat how to balance. You should know. You will get 1, 3, 3, 1. And after this, we start to have the question mark box. So my question mark is molarity of aluminum chloride. So I have to, underneath aluminum chloride, I put question mark molar, change it to question mark mole over L. And then the bottom will be the honey. Again, the question mark box, the question mark always on the top, and then the honey will be on the bottom. So another information for aluminum chloride is 38.20 meter. So we need to put that on the bottom of the question mark and then change to liter. And then for the question, the non-question mark box, the top one is always something measurable. So here we have to put 20 ml underneath silver acetate. We change the ml to liter. And then the bottom will be whatever left over, whatever the honey, which is 0.0050 molar, we change to mole over L. After we have this 4 information, we start to draw the arrow. Again, we always start with non-question mark box. Okay, we want to start with everything there. So we draw the arrow from this direction to this direction, and MR will be in the middle. So then we can start to follow the map. So the first piece information is from silver acetate, 0.020 liter, silver nitrate. And then we follow the arrow, we have to put 0.005 mole, 0.0050 mole over L. Now again, it's silver acetate, okay? We are on the same side. So here we have to put 1 L on the bottom because you want to cancel the L. And then the 0.0050 mole on the top, silver acetate. So L and silver acetate cancel. And then after this, we jump to this arrow will be MR. Now MR is the molar ratio between aluminum chloride and silver acetate. So it's 1:3 ratio. Again, which one is on the bottom? You have to look it up. Okay, this is silver acetate, then this must be silver acetate. Silver acetate is 3 mole, then you put 3 mole. And then on the top will be 1 mole AlCl3. So now here, mole and mole, silver acetate cancel. After the MR, we jump to the silver chloride side, will be the liter, 0.03820 liter of aluminum chloride. So if you look up here, you should not put the liter again on the top because my molarity, I'm looking for molarity, should be mole over L. So the liter should be on the bottom. Now here, nothing will be cancelled. So mole and L, no cancel. You don't even need to cancel the compound here because we can have that at the end. So after you do all your math, you should get this number. Now this number is very small, okay? You see that a lot of zeros. So my answer is actually suggest you want to move to the right hand side 4 times 0 until you get the number between 1 to 9.999. So you move 4 places. Originally, this number is less than 1, so my exponent will be negative. And I round to 2 places will be 8.73 times 10 to the power negative 4. Mole over L, we change back to molar, NaLCl3. So this is another kind of a double displacement. This one is a regular double displacement, not neutralization, but it's the same way is you have to draw the rainbow and then switch the partner, balance the equation, and then you start with the question mark box, and then the non-question mark box, and you draw the map from the non-question mark. You start with everything that I have. You draw the map with the emerald in the middle. Then you can follow the arrow and make sure be careful what is on the bottom, what is on the top. Then you cancel everything. Then you will get the right answer.